Okay, here's the review. Mrs. Leonard conducted a survey in the city of Tampa to estimate the proportion of cars that are red. A simple random sample of 25 cars from a parking lot at her school, Red Eagle High School, was selected. Which with the following statements is correct? So that was kind of a convenient sample. I don't love that. It's just from her school, and we're trying to get all of Tampa, the whole city of Tampa. So I don't love this one, but let's look at the answer and see if we can eliminate some. Because this is a simple random sample, it should, well, it's actually a convenient sample, I think. Um, I guess it was a simple random sample of cars in a parking lot, but I think we're trying to estimate all of Tampa. Um, at least that's what the first line said. If a simple random sample of 15 cars were selected, we would expect the same amount of variability. No, that might be the answer. I'm just guessing. We would expect there to be sampling variability. If someone else took a survey, you might get different answers. An alternate method of getting a representative sample would be to select the 25 cars closest to a specific location. Um, Again, I think it's city of Tampa. I just don't like that answer. Maybe this is a poorly written question. A different individual doing the sampling independently would probably attain a slightly different answer. So, well, that's true too. So it's one of those. This is an example of perspective. No, it's not perspective. It's not looking into the future. Sample of 15 cars were selected. We would expect the same amount of variability as we would. No, that's not true. I read that one wrong the first time. We wouldn't expect it to be the same. I thought they were saying it would not be the same. It wouldn't be the same. So it's definitely D. Sorry about that. Okay, we divide the class into two groups, first year students and others. So we're kind of grouping them by some similar quality. We take random samples of each group. This sounds like, so we had similar groups because we had first year students together, so that's stratified. We only took a simple random sample inside of each group. Systematic would be going every fifth person or something. Multi-stage, we don't even know what that is in AP Stats. Cluster samplings when you have heterogeneous groups and you do a census inside of each group. And simple random samplings when you don't group at all. So it's got to be D. Okay, marine biologist wants to estimate the mean size of a barnacle on a stretch of rocky shoreline. To do so, he randomly selects 20 10 by 10 inch plots and measures the size of every barnacle in each plot. This is an example of, so again, this would be cluster because it's like a census inside of each group, but each group might be, heterogeneous. I think it's got to be cluster. School district is considering going from traditional school to year-round school. Oh, school district wants to estimate the proportion of parents that are in favor of year-round schooling. So at open house, who comes to open house? The gung-ho parents, right? Not the bad parents. I'm being silly there about the bad parents. At open house, surveys are sent out to a welcome table for parents to fill out if they want. Of the 251 surveys completed, 63% of parents. So even besides the fact that only the gung-ho parents come to open house, the other issue is that they have a survey that's optional at the open house. So only if you feel really strongly about this are you even responding to the survey. Are you really just an incredible parent? Which is following is true about the sample proportion. So it is probably biased. Those look tempting. It's definitely voluntary response sampling, so I'm leaning towards A right away. Definitely not convenience or random. Sample is not biased. That's not true. Sample is not, no, that's not true. So it's got to be A. Farmer wishes to determine which of the two brands of baby pig pellets produces better weight gains. Two of his sows or pigs each give birth to litters of 10 pigs on the same day. So he decides to give the baby pigs in litter A only Ken pellets, and litter B only the Mormon pellets. After 4 weeks, the average weight gain for the litter A is greater than the average weight gain for litter B. They feel like the feed that is is not the only factor affecting the rate at which pigs gain weight. Genetic differences also affect weight gain. Oh, that's true. It's likely that pigs in litter A are genetically different from pigs in litter B because the two litters have different mothers, because the farmer is only interested in determining which brand of pellets is better. That's called confounding, right? The other issue is the genetics, right? You got two totally different genetic groups. It might be because of genetics. We don't know. Researchers observed that on average, the number of divorcees in cities and Major League Baseball teams is larger than those without teams. Well, probably because the cities are larger. Only large cities have Major League Baseball team. We don't even have one in Memphis, which is following the most plausible explanation for this observed association. Major League Baseball causes divorces to rise. I don't think so. The high number is responsible for the presence of the associations due to confounding tend to be in large cities. Hence, I think that might be it. The association makes no sense because many married couples go to the ballpark. The association is purely coincidental, is implausible to believe. Okay, so it's got to be C. Mr. Miller wants to study the effects of storage time, so different lengths of time, on the amount of vitamin C present in dried fruit when stored different lengths of time. 6 fruit packs were randomly assigned to each of the 3 storage times. The treatment, experimental units, and response variable are respectively what? So the treatment is the storage time. So it could be A, it could be D, or that one, but those are gone. The measured response variable, I'm going to go to the last one first. We're measuring, it seems like we're measuring the amount of vitamin C here. So I don't think it's the fruit pack. And so is it D or E there? Okay, so the experimental unit, I think, would be the fruit pack. I think it'd be D. What is the purpose of random assignment? To create roughly, oh, I love it, roughly equivalent groups. That's exactly it. And if it's statistically significant, we might have cause and effect. Okay, this one, an experiment was conducted to see if listening to music will increase retention of material. 40 student volunteers at a college were randomly assigned to one of 2 groups of 20. The first group listened to the teacher lecture with music playing. The second group just listened to the teacher lecture. After the lecture, students were given a test on the material. Kind of like this. 13 of the groups in group 1 passed the test. And 11 of the students in group 2 passed the test. Thus, the difference in proportion of students who passed was 10%. 50 trials were performed to see what the difference in proportion would occur just by chance alone. Here's the dot plot of all those simulations. There's 50, I guess, simulations. So it looks like 10% is here, and we always want to go that or more extreme. So if you count the number of dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 out of 50, or 22%, I'm pretty sure that is. So that's not that unusual. We want less than 5%. We got 22%. So okay, I don't know what the answer is. Let's see. Because the center of the graph is 0, the difference, yeah. Because 0.1 was not the most frequent result. The difference is not. 0.1 or greater is somewhat likely to occur. This difference is statistically significant. I don't think so. It's not significant. Or greater. I like the way it says that. Is somewhat likely to occur. The difference is not significant. It is likely to get a difference from random assignment to groups. I think that's it. Company has developed a new product called Plant Grower Fertilizer. They claim the new product will help plants grow faster and taller than plants that do not receive the product. Okay, to test this, the company designs an experiment. There's 20 planter boxes. In 10 randomly selected planter boxes, plant grower fertilizer is added to the soil, and the other 10 planter boxes do not receive added fertilizer. Besides the added fertilizer to the soil, each planter box is treated the same. Water used to grow plants At the end of the experiment, the average height of the plants for each type of planter box is computed to see if the new fertilizer does help plants grow faster and taller. Which of the following identifies the control group, and why was it necessary to have a control group? I like A a lot. I don't know if I have to keep reading here. With no added fertilizer. I think A's got to be it. Okay, to investigate the relationship between a job a person holds and their success on the dating site, a young man created 2 profiles. He kept all of the information the same except for his job. In one profile, he said he was a cancer researcher. Another one, he said he worked in the mall. He was concerned the profiles would be flagged if they used the same picture, so he actually changed the picture, gave himself like let's see, a suit in the library, and then the mall one, he just a picture of himself in a T-shirt in his mom's basement, I think, or something. The researcher profile resulted in much more interest than the mall profile. Shocking. Based on this study, is it reasonable to conclude the type of job caused the increase? So we have a confounding variable here, right? So we don't know. So you want to relate. So the confounding variable is the picture. So how is the picture related to the mall? So to the 2 profiles. So we had the 2 profiles. One, the mall one, it's related because he took a picture in his T-shirt, which didn't look as good. So I don't know if it was that he worked at the mall or because he just wore a ratty old T-shirt in his mom's basement. And then how does the confounding pick relate to the researcher? Well, he looks sharp. He's in a suit. So that might have made him pick that. Maybe it was that and not the actual job. So you want to relate the confounding pick to both. Definitely want to read that answer key. So you just want to read that and just compare it to my answer to make sure it looks okay. Students in a large stats class were randomly divided into 2 groups of 20. One group, so just randomly, so one group took the midterm exam with soft music playing. The other group took the exam with no music playing. The average scores of the 2 groups in the exam were compared. Describe how random assignment could have been carried out using technology. So we're just kind of like getting a treatment group and a non-treatment group, essentially. So you could have assigned numbers. So number 1, you assign numbers to every person. I guess in this case, it would be 1 through 40. Yeah. Okay, so then you use a random number generator to generate numbers to get, let's see, get 20 unique numbers from 1 to 40. That's important to say, unique or no repeats. The third section is you must identify the 20 individuals, the 20 people, identify the 20 people who represented by those numbers. Outline a completely randomized design for this experiment. So completely randomized. So I'm thinking, so you've got the 40 students in a large class, the 40 stat students. So you randomly, random SRS, right, SRS, get them into group 1, and group 2. So you're going to apply the treatment to one of the groups. So they get the music, and this one gets no music. And then they come back and evaluate. See what they did on that one. Oh, I forgot to say how many students. I like how they said treatment 1, treatment 2. That's a nice touch. Random assignment of treatment. So random, I guess I call it SRS. I think it'd be better since we're applying a treatment. It's a random assignment there. I like that wording better. The third thing there, so the results of the experiment showed there was a statistically significant difference in the average scores of the two groups. Explain what it means in that context. So you're comparing that to just by chance alone. So the results we got were not, could not be explained by just chance alone, but they actually seem to be a large difference from what we expected there. So C, they said, is unlikely to get a difference as big as this simply due to chance variation in the random assignment. So that's what that means. And 13, finally, study is conducted to see if the relationship between how happy someone feels and the amount of time they spend commuting to work each day. 50 workers at a large retail store were randomly selected and asked to rate their happiness on a scale of 1 to 10, and asked how long their commute to work was each day. The results show that workers with a commute time of less than 15 minutes rate themselves significantly happier than workers with a commute time of more than 15 minutes. Can the results be generalized to all workers in this retail store? And can it be concluded that a shorter commute time causes an increase in happiness? Really good questions. So they were randomly selected. So we can, to answer the first question, can the results be generalized to the large retail store? The answer is yes, they can be, because we have random selection. But is this even an experiment here? There's no experiment, so can we prove causation? So no, we can't prove that. Let's see what they said for 13. Sample was randomly chosen. They can be generalized to all employees of the store. However, it's not an experiment, so cause and effect. We don't have roughly equivalent groups. We don't have significant results. We can't be determined. Okay, I guess that was kind of a short review there. Okay, so that's the review for today.